Hello friends, my name is Nasir and you are most welcome in Laptex. You must remember that few days before I asked a question about how does a 3.3 and 5 volt regulator work and how do you determine that whether IC is okay or it's malfunctioning. I am really thankful to you that across the country I got answer and most of them was right to some extent, but unfortunately the main answer which I asked, that what is interrupt, was quite wrong. So today I am here with you to reveal that mystery about 3.3 and 5 volt regulator, which is quite essential to identify that whether IC is working fine or it is in bad condition. So this is my humble request to you. Don't try to skip this video at any point of time. Otherwise, I think you will get confused and consequently you will not understand the actual concept of 3.3 and 5 volt buck regulator. I hope that you will enjoy after watching this video and your concept will be more clear and crystal after knowing all the fact about the 3.3 and 5 volt regulator. Now let's come and see the how does it work. Hello friends, welcome again. And today I am present with the answer of those questions which I asked few days before regarding 3.3 and 5 volt buck regulator. And I asked that what is the function pins which is required to initialize this buck regulator, and how do you determine that this IC is working fine or whether it is malfunctioning and you need to replace the particular buck regulator. So as of now you have been working with the hit and try, most of the people, because I got more than 50 answers regarding this question, and unfortunately I did not get even a single answer from the Apple logic board. So let's forget about the Apple. Now let's talk about the basic logic of 3.3 and 5 volt buck regulator, that how do you determine that whether it is okay or it is being enabled, and now you are expecting to get the output voltage on the given coil. So I'm really very thankful to the people who has answered me, and really they have appreciated a lot that due to this questions something new has been revealed, that the very new things they came to know about that, and somebody has dared to answer my questions with the reference that yes, this happens like that according to me. I really appreciate those guys who has really a curiosity to learn, and because this is the knowledge which will lead you to the success, and you just repair, you will get perfection by learning only. So here I am present with the same schematics which I asked last time, but one thing, the one answer I got, I will not reveal his name, but one of my friend, he wrote like that, and he really study hard, that he tried to answer me, and he told me that sir, I do not repair Apple motherboard, but I would like to give your two answer. And he gave me answer of Dell 3521 model, which I asked, and second one was HP motherboard R13, and he also dared to answer. He tried his level best, and the procedure was quite right, but unfortunately the answer was wrong, which I highlighted it with the green color. So all the procedure was quite right what he wrote here, and also you should be aware about this. Just pay attention here. Interrupt 1 will high with available 1.2 volt voltage on the pin number 1. This is wrong answer, because you cannot prove it that it would be 1.2 volt. One thing, to start 5 volt, always internal PWM sections to generate 5 volt. This point is right. On the same time, in trip 2 will available 1.2 volt on the pin number 6. This is also wrong. And start operating 3.3 volt internal PWM sections to avail 3.3 volt always. This one was right, that first 5 volt will initialize and then through the PWM switching, then 3.3 volt will be available on the motherboard. Here, when VL is available on the gate PQ206, it was the Dell 3521. You can see on the motherboard as he wrote. Here, when VL is available on gate of PQ206, interrupt 1 and interrupt 2 will be deactivated status due to connectivity to ground. This is quite right, that any enable voltage, if goes ground, will stop working. So this is quite right. Here, enable pin 13 is not connected, no function. Not connected is okay, my brother, but not function is quite wrong, because there is the lots of function, and that is the very crucial part. And I will prove you that how does that function. By interrupt 1 and interrupt 2 logic circuit is game changer. Absolutely, that is the game changer, and that change the game and convert into 3.3 volt and 5 volt, and you get on the coil. However, whatever voltage you get on the coil, where you try always find out 3.3 and 5 volt, that is the not output, that is even input. Even I will prove that that is not output voltage, but that is rather input voltage, and 3.3 and so on. And I think the crux of the answer is that interrupt will be 1.2 volt on the both pin number 1 and pin number 2, but I think this is wrong, and I will prove it. And let's come towards the second answer, which I went through. These are the steps which I have already described. That's how does it work. And here, due to resistance decoupling on the both interrupt 1 and interrupt 2 pin to maintain voltage between 0.5 to volt, it is quite obvious that the voltage would be on the steady state. If the voltage goes from the interrupt 1 or interrupt 2, it will stop working. So there always you will find voltage on the steady state. Remain, you will get the voltage on that both point. In practical, in both pin, approx 1 voltage available for both terminal PWM sections operational. And here you cannot determine that whether it is 1 volt, as you wrote on the first one that there would be 1.2 volt, and here you are writing in practical there is 1 volt. So it is also wrong. Look, these all about the theories. If you have gone through the schematic, internal schematic, there is always minimum or maximum level check by given VIN 12 volt and certain current has been given, and then you have got this voltage and this voltage. That is the minimum level and maximum level. But that is not the way you can determine that this is the voltage which you are expected to get on that particular pin. So I think you are still not damn sure that there would be 1 volt on this pin. Later, if we fix, and this my brother has given this answer that which was slightly differed to me, which I asked at last of the normal generic laptops, and the question was that if I put, instead of 110 kilo ohm resistance, if I place here 210 kilo ohm, what would happen here? As he answered to this question that if we fix high value resistor instead of existing resistor, then resistor will pass more voltage to ground. It means the rather voltage will go in the ground, and due to less voltage on IC, it means IC will receive less voltage. Since no enable, then automatically IC's internal logic and PWM's sections will stop function. This is also not right. So overall, I really appreciate you that you really have a passion to understand that how does it work, and this types of lots of answer I got from across India, and even there was lots of complaint that personally I got from the abroad that it seems that you asked something, and had it been in English, then I would have dared to answer your question. So this answer is seems that when we used to make the maths in our exams, and all the procedure was right, and but answer is wrong. To the maximum extent it was right, but overall the only answer was wrong, that you cannot determine. Look, the purpose of making this video is only that you can determine within a minute that how you can judge this IC is okay or faulty, or has this IC got all the inputs, then you are expecting the outputs. Look, it cannot happen without seeing the input voltage you start checking the output voltage. So as far as my knowledge is concerned regarding this structure IC, this has 6 or 7 inputs, and among them I would like to shed light on few of them which I asked questions. So let's friend come and see that how I check this IC, and I will try to prove that that is the right way to check this particular IC, which is TPS 51123 or RT8223 or RT8505 or TPS 51125. These types of structure IC has always same types of function pins. There might be slightest of difference could be on the pins, like here you see pin number 18 is a given voltage, the enable voltage is on the pin number 18, but in Dell motherboard you do not get voltage on this pin. So overall here you need to understand only that which pin can determine you what is the main root cause of that fault, which can lead you to replace the IC, not hit and dry. Let's come and talk about from the beginning, the very beginning. I check this particular IC with 3 steps, and that is the enable steps after getting the VIN. As soon as I get the VIN in this IC, and this IC internal logic linear regulator, it automatically generates some current, in that is also called independent current source, and also it generates some reference voltage, that is called independent voltage source. If we talk about the this enable pin, as my brother wrote in his answer that it is NC pin, not connected and no function, but here there is a lots of function and very important, very vital pin which you have to check here. You can see that there is the star marks and it is not present in the motherboard, but despite, if you see on the internal diagram, let's come on the internal diagram and see this point enable 0. This is called soft start. One thing, soft start means that you will get some reference voltage from anywhere, and it must be greater than the threshold voltage, and then it will pass through this oscillator and it become enable voltage for main LDO. And if you talk about these types of structure which I was talking about, and this IC use 3 main LDO. First is the reference volt LDO, second is 5 volt VRAGE, this is also LDO, and third and last one is VRAGE 3 LDO. All 3 LDO, if it is in the good condition, if it is working fine, then you definitely will get more voltage than the reference voltage which is given on the negative terminal. So in practical motherboard, you can check the voltage 2 to 3 volt you will get here, and it could be connected with any of the reference voltage. It will get the voltage as per internal logic, and as far as this board is concerned, you will get 3.3 volt around on this pin. You always have to remember, as of now you have not been checking this pin. Two things I will tell you about this EN0 pin or pin number 13 of the TPS 5025 or these types of structure which I told you about, that you will always get more than 2 voltage as per my experience. And this pin should be open from the ground, and there should not be a beep sound or there should not be shorting on this pin. If there is a shorting, it direct mean that your either of one LDO is malfunctioning, it is faulty. Any of one could be faulty and the reflection will go back to the EN0. As per experience, 2 volt, more than 2 volt you will get on this point. You can check and you can confirm it. When you get voltage on this terminal, then definitely the positive terminal will pass and it becomes EN, and EN is going to activate. Look, this soft start is also called control pin. I mean that reference voltage and 5 voltage and 3 voltage always, that is LDO voltage, which is being controlled through this enable, and this enable is coming out from the independent soft start source. So this is the first step of checking, that you just do one thing, go on the pin number 13 and check shorting. It should not be less impedance from the ground. If there is a suspicion that you have suspicion that this pin is short, do one thing, you just plug in power and see that what is the condition of voltage. If you get voltage on this pin, you need not to check the LDO voltage. It will tell you that LDO, all LDOs are okay. Might be this capacitor could be leaky, that is the exception case, but it tells you all 3 LDO are okay. So through one pin you can determine these all always voltage along with the reference are okay. I think you would have understood that how pin number 13 EN0 function. So let's move to the other point which always I check, that is the ENC, and most of the guy answer me that yes, this is the enable pin, but in this there is a no enable pin. It means it is directly enabled through the LDO. This LDO is internally connected, also connected with this input. This is also input. I will prove you later in my class. If you join my class, I can prove you that this is input voltage, that this is not the output of this particular buck regulator. Whosoever answered me, he told me that yes, ENC is to activate the suspend state, and you would be able to see the voltage on the coil after coming this one. So that was the quite right. The focus of my question was on the N trip, and let's come and see that how does it work, and how you can determine that what voltage should be here on this point and on this point. This was the crux of my question, that how do you determine that what voltage would be here, and instead of 110 kilo ohm, if you place here 210 kilo ohm, what will happen here? So let me answer to your question. So here, and now you would have understood that how does it enable, and what is the role of ENC. ENC is something that if you cross it, then it will not, the both logic will not, first I forgot to tell you, that's why I'm repeating it. If ENC 18 number pin will get the voltage and if it is more than 1.26 voltage, that is the minimum threshold voltage. Like if it gets 3 voltage from controller IO, it will reach here, and first it will activate this controller EN1, and I think EN1 is the 5 volt because it would be connected is the VRH 5. Then it will start PWM switching to get output voltage as per your information, that is also input. We will talk about later that that coil is the input or output, but you start getting voltage on that particular coil, and there is the 1.6 millisecond delay between this regulator and this regulator. So even that is not matter of very concern that what delay would take place. But main thing is that the both will get the voltage simultaneously if you don't defer it with the time. Both internal logic 3 volt and 5 volt 5 volt and 3 volt internal logic will be enabled through this ENC if there is. If there is no ENC, then Interip is responsible to enable the particularly one this IC. Then Interip 1 and Interip 2 will start working as per required criteria. And what are those criteria? Let me tell you. These are the things which allows that Interip to activate. Like here is the OOA control. This is auto off audio. Like if frequency noise is too much, then rather than 2 volt, then it will stop working. If under voltage is less to the 2 volt or 40% of the input volt, then it will stop working. If over voltage is rather than 2 volt, then it will stop working. So if all the criteria are matched, if all the input and output is okay, there is no shorting, then this IC, this particular IC will generate 10 microampere independent source. Like here you can see that this IC has the 1.8 volt independent voltage. That this IC, after getting the VIN voltage, this IC start this voltage as a reference voltage. Internally it has been designed or programmed that if V ought is greater than, like here, if V ought is greater than the 5.75 volt, then it will off. I mean to say that voltage ought cannot be greater than 5.75 volt at any cost. Otherwise it will switch off and you will not get the pulse. This flip-flop will stop working and you will not get any PWM pulse on the high channel and low channel MOSFET. So this is the procedure. If all the criteria are okay, then definitely you will get the 10 microampere independent source will be generated. And how you can determine that it is the exactly 10 microampere current source? Look through this resistor. And you all people has given answer that there would be someone wrote that 1 volt, someone wrote that 1.5 volt, someone write that 1.2 volt, 2 volt, something like that. But my brother, in this way you cannot determine. Suppose here if I get 0.8 volt, can I presume that it is okay? Instead of 0.18 volt, if I get 1.8 volt, can I determine that this IC is okay? No, not at all. Unless you calculate it, that's whether voltage is okay or not. So first thing first, I would like to see Interip, that actual meaning is, according to me, enable plus trip. Enable is responsible to enable any IC or any logic. A trip is when it sees that something is going wrong, it will stop working. This IC will begin through the enable from the same pin, and this IC will stop functioning with the same pin. So both working simultaneously. So this is called Interip. One thing. And how does it function? As per the Ohm's law, V is equal to I into R. Like that. So you will get the voltage if you know ampere and if you know resistor. So if you calculate it, at last of the video, I will show you that how you can calculate that what voltage you will get on this point. Here I can say you, as per 110 kilo ohm resistance, I will get 1.1 volt on this pin number 1. And as per 130 kilo ohm resistance, I will get 1.3 volt on this pin. And the question which was asked by me, that instead of 110 kilo ohm, if I place 210 kilo ohm resistance, then the answer would be 2.1 volt I will get on the pin number 1. However, the internal logic will not initialize as per the internal circuit. The logic level says that here it should not be greater than 1.8 volt. That was the different thing. That my question was that what voltage will I get on this point? So not a single answer I found right, that you will get this particular voltage on this pin number 1 and this particular voltage on. If you have differentiated it, I would have given you my free class every Saturday on the Zoom or on the Hangout. By the way, none of the answer I found right. So let's hope it is not matter that you only repair the things. Suppose there is a no 3.3 and 5 volt, and you just exhausted with the all avenues to replace like 3.3 volt regulator and these upper and lower MOSFET you replaced, even these MOSFET you replaced. At last these PF, all these PF, it will make you a puzzle that what you have to do. Now you will think about the controller IO. Let's change the controller IO. This is nothing but hit and try. And my friend, my motto is that you should be perfect if you are in the repairing line. It will really make your life very easy, and after testing it will make your confidence very high. The matter is that this will help you to finalize the work or to repair the work or to accomplish the target within the given time. And I think in order to check this IC, it will not take more than 5 minutes. You can judge that this is not working. Like here, if I do not get 1.1 volt on this particular pin, I will determine that no, this resistance is not functioning, or internal 10 milliampere is not working. First I will check only this resistor. If resistor is okay, then I can determine anyhow internal 10 microampere is not being generated, so let's change the IC. If I get the both voltage proper, and despite I do not get the voltage, maybe internal switcher is faulty. Maybe there could be because you have no option to check all the internal logic. Like here, this flip-flop you cannot check, but I can tell you that how does it work, but I just don't want to go into deep. So many types of problem you daily confront, and you have to struggle a lot in order to get the 3.3 and 5 volt. So after working on the same procedure, I hope that you will really thank to me that I made this video, really. And don't feel shy to thank me if this video is helpful to you. And I hope that you would have understood whatever I was trying to say, that each and every logic has the different types of function, different types of structure. You will have to reach on the root cause of the problem and then try to rectify it. It will really build up your confidence, and it will save your time, it will save your money, it will save your energy. And here the most last time I did not show you, this is the very interesting part. That's why I am just trying to describe particular schematic. This is the Dell N5010, very common and very famous motherboard. And here is the procedure to activate the N-trip is slightly different. That's why I am trying to shed the light on this issue. Here it is written that 51125 N-trip 2 and N-trip 1. And if you look above of the schematic, you will find out that remain pin here, it's not here, but you will find it's connected on this line 1, and 2 is connected with this line. However, you are not getting any connecting terminal on this point. That's why you will get confused that where is it coming from. It is exactly coming from on this point, pin number 1 and pin number 6. Pin number 1 is N-trip 1. See here, N-trip 1 is here. Now the situation is like that. If anyhow your ground reach on the 6 number pin after switching the N channel, as you know that it is N channel, and when this N channel will get voltage on the gate, the source ground will travel to the drain, and ground will reach to the end trip and end trip will be 0. Then it will not activate. You will not get voltage on the coil. But if you want to know that how will it work, it is required 3.3 and 5 volt enable voltage, which is previously coming from the S5 on, and that particular signal is coming from the controller IO. And overall you can say this particular pin is directly coming from the controller IO, and controller IO allowing this enhancement type of MOSFET gate to go ground. This source ground will reach to the drain, and this ground will go here, and it will stop this 3.3 volt to travel on this area. So here you will find 0 voltage. After getting this voltage, you will get no voltage at any cost on this point. On this terminal you will get 3.3 volt, but here on this terminal you should not get any voltage at all. And the same rail is going here, and it is entering in on the pin number 2 as well as on the pin number 5, the both terminal gate, the both channel gate it is going. And as soon as it will go, it means the ground is going. That means that is the 0 voltage, and the 0 voltage will not switch on this channel or this channel. Then it will be deactivated with this ground, and it will be open. It will not be ground. Then what happened? This pin is directly connected with the pin number 1. Then what happened? Pin number 1 is connected with the 76 kilo ohm resistor, and it will allow to calculate the 10 microampere into 76 kilo ohm, and you will get according voltage as per your calculation. In this way you can get the enable voltage. This is the master enable of the IC, which allows 3.3 and 5 volt buck regulator to start the PWM. This is the entry pin which allowing this circuit to convert into the PWM through this logic. Here is the things. So this is just a basic fundamental things which I am talking about. There is a lots more about this 3.3 and 5 volt regulator which you need to know. Let me show you in practical that what voltage I get on the pin number 13. As I told you that there was with the proof and with the testimonial, that this is the testimonial you can say. And here on the N trip 1 and N trip 2, what voltage you will get as per calculation. Let's see both things, calculations as well as on the practical. I think this video would be very helpful to you, and please like and share and subscribe for the more updates. Hello friends, so this is the thing I was talking about in schematics. Now try to understand. There is a very few mathematical calculation in this point. What you have to determine in this point, that the name you can also remember, as you know very well, the pico and nano, micro and milli. Here only the thing, in order to get that particular calculation, what you are needed, the syntax you can use at the time when I will calculate the things. That is why I have written this thing, so that you can easily calculate that particular in-trip voltage on the ground of this particular things. As there is the 10 microampere is given on that point. So 10 microampere you can write 10 to the power minus 6. This is the point you have to calculate. You need to remember the name and the signals and the syntax as well. If you want to calculate, if somewhere has been given millicurrent or somewhere has been given microcurrent, sometime you have to calculate the time with the same things. Sometime you have to calculate the same things in the CRO. So this would be very much helpful if you know the syntax of this particular names like pico, nano, micro, milli, and the kilo, mega, giga and tera. So let's come and calculate. As you have seen in the schematic that there is the 110 kilo ohm resistor. So you know the R, and now you know the microampere. You can write 10 to the power minus 6. and the voltage you have to get V is equal to I into R. So this is what you need to understand, that there is the only Ohm's law where you have to calculate through this formula and you will get the answer. So let's come and calculate it. So now see, I have made a 3.3 and 5 volt buck regulator design as you have seen in the schematic. Only just for the calculation I have made it. So here is the point that interrupt 1 is 110 kilo ohm and interrupt 2 is 130 kilo ohm. How you will calculate it? You just pay attention here. As you know, V is equal to I into R. So now here V is equal to, you can write I is the 10 microampere into R is your 1. First I am just calculating this one into 110. So 10 microampere into 10 to the power minus 6. As you have seen before, the syntax was there, and into 110 kilo ohm. Now you have to convert into ohm, and as you have seen earlier, as I wrote that what can you write to the kilo ohm? 10 to the power plus 3. So here 10 into 10 to the power plus 3 and 10 to the power minus 3. So it is 10 to the power minus 6 and it is 10 to the power plus 3. I just cut off and rest is 10 to the power minus 3. Now 10 into 110 into 10 to the power minus 3. Now the very easy calculation. Now you have to bring it down and it will become 1000, because the 10 to the power minus 3 is the 1 kilo ohm. 10 10 10 10 is equal to 11.10. Here the voltage you will get 1.1 volt. Here on this particular pin, on this terminal, you will get 1.1 volt. Okay, and the same thing you have to calculate here, and you will get on this terminal, you will get 1.30 voltage. So this is the way you can determine that what voltage you are going to get on the interrupt pin. Then you can expect that your regulator is working fine to some extent, because not fully you can determine. However, there is the two switchers are there, and that is the independent switcher for the 3.3 and 5 volt. So if independent switcher are faulty, then despite you will not get output of 3.3 or 5 volt. This is the way you can calculate this particular voltage, and you can determine that yes, exactly this voltage I need to get as per the resistance. Exactly the same voltage you will get on this point as per your resistance. So I think that you would have understood that how you have to calculate these things, and you will get the voltage as per your resistor. This is the point that determines that your 10 microampere inside your buck controller is working fine. That indicates that your entire logic is okay. If you are getting this voltage on this point, that indicates that your internal logic is working fine, and it has generated 10 microampere in the buck regulator, and through this resistor it is being calculated like that. So this is the Ohm's law, very easy calculation. You can calculate and you can get the voltage as per your resistance value, because it is very constant. This is the 10 microampere for the interrupt one, as well as 10 microampere for the interrupt 2. So on the both point you are getting the same current, but the resistance, as you will change the resistance, you will get the different voltages as per the resistance value. So I hope that this will help you to calculate any types of interrupt voltage. If the slightest of resistance value is changed, you can easily calculate through this calculation. So as I asked the question, that's what you are going to get voltage instead of 110 kilo ohm. If you place here 210 kilo ohm, then you are going to get the voltage as per, if you calculate it, then 2.1 volt you are going to get. However, it will not switch on because the threshold value of that internal comparator is 1.8 volt. Because it is on the negative terminal, it will switch off your buck regulator. So that was the different thing. I just asked that what voltage you are going to get on this point. It is 2.1 volt as per this calculation. So I hope that this will help you to calculate. Now let's come and see the practical. Hello guys, and as you have gone through the theoretical session and as well as on the whiteboard, I have calculated that how you have to determine that what voltage you are going to get on the interrupt 1 and as well as on interrupt 2. So here hardly you will get TPS 51123 IC that which is used for the always voltage, and in all types of HP model perhaps you will get suspend voltage. However, it is depend on the architecture of the motherboard. Here the same IC is used. This is Toshiba model, Toshiba 850, and TPS 51123 is used here. And the very unique thing you will see, however, depends on the how does architecture is working. So now you are getting here 3.3 and 5 voltage always, and the reason behind it, why are you getting always, because the pin number, as I told you, that if you are getting 18 number pin through this logic directly, because the two types of IC comes, like where you do not have 18 number pin for the use, the direct LDO voltage is switched to the PWM through the interrupt pin, and this is the IC where 18 number pin, which is ENC pin, this voltage, particular voltage is required. As you can see that 3.3, if you provide this IC, it will generate the voltage. But how will it generate the voltage? You cannot determine that after getting the voltage you will get output, provided that you need to get the interrupt 1 and interrupt 2 voltage. But as I have described you in the schematic, that first what you have to check, as of now you have been skipping point, as I have told you about the EN0, which is on the pin number 13, you will always get more voltage to the 0.5 volt, as there is the comparator threshold voltage is 0.5 volt. So here you can see that 3.4 volt you are going to get, as internally it is designed and it is connected with the internal logic of the any of LDO. So here at least more than 2 volt you need to get to determine that your internal 2 volt, 3.3 volt and 5 volt LDO are okay. So through this pin you can determine that your internal LDO is okay. So this is the first step you have to check. And the second step I was talking about, that is the ENC. So however, the TPS 523 is used here, so definitely you need to get this particular voltage on this pin in order to initialize this IC. And they are the like a coding IC, EM is equal to like these types of IC as you have seen in 3521 model. This voltage is not required as there is the only entry pin which is just sensing that if all the internal logics are okay, it will generate 10 microampere and it will switch LDO voltage to the PWM. That is the main point where this transition take place. So, and the third number, and now come to the third number, and as I told you, this is the entry pin, and you can determine as per the resistance value to calculate with the 10 microampere current which is going to be generated inside the 3.3 and buck regulator if the buck regulator is okay. So here through this point you can determine that your 3.3 and 5 volt buck regulator is working fine, and now you are going to get the 3.3 volt and 5 volt on the given coil. So 1.5 volt you are getting here just because there would be, as of now I haven't seen that what resistance would be there on this place, but I can say that 140 kilo ohm resistance must be on this place if I am getting 1.40 voltage. And on the pin number 6, I am getting 1.21 voltage as per the 120 kilo ohm resistance on the pin number 6. This allows me to determine that yes, internal logic is functioning very well. Internal 10 microampere has been generated. So let's get the output on the coil. If you are not getting, maybe your switcher could be faulty inside the 3.3 and 5 volt buck regulator, and the output MOSFET, high gate MOSFET and the low gate MOSFET could be faulty in that point of time if you are not getting the output after, even if you are having entry voltage on the particular pin. So I hope that now let me show you that are you really going to get the same voltage. So this is the TPS 51123 IC, and the pin number 1, as you were getting 1.4. so as I told you that there might be 140 kilo ohm resistor, and that will determine you what voltage you are going to get on this particular pin. And on pin number 6 you was getting 1.20 voltage as per 120 kilo ohm resistance, and the tolerance you can see the only 1%. So that is why I asked a question through my YouTube video that if you place here 220 and whatever, anybody shift it, or it is there is a corrosion on the resistor, so you will not get that voltage on this particular pin, and you will think that yes, I am getting 0.5 volt, that might be okay. But not, friend, that is not the right concept to work. Here is the concept that it will determine you that if you place here 130 kilo ohm, then definitely you will get 1.3 volt on this particular pin. I hope guys that this video would clear your more concept, that as of now you are working on the hit and try, but from now you will pay attention that what the voltage you are getting on this particular pin, and there are the so many logics which is working behind it. As of now, this is not the complete thing. As I have told you, I was just describing those things as I asked in my question, but there are lots of things to learn about this. I hope guys that this video would be very much helpful to you for your reference, for your perfection. So thank you guys, thank you for watching this video. Please like and share for the more updates.